All right, my growth mindset math maniac math Panthers. Area of a rectangle, area of a parallelogram. Here are some rectangles. How would you find the area of these rectangles? One popular way is to count them. Count Dracula, Count Chocula, count the count. What's the count on Sesame Street? Count them. I love to count. And it's red. I wonder why it's red. Could be blood drops. Oh, that's morbid. Sorry. Take it back. Don't say it. 1, 2, 3, 4, 5, 6. It's 6 squares. 6 squares. But what are the units? We'll just put U for now. Like U. Not Y-O-U. Just U for like units. Short for units. Okay. So that would be, we would write it like this. 6 units a squared. So if it were centimeters, like if this were 1 centimeter and this were like 1 by 1 centimeter, like each little thing was a centimeter by centimeter, that'd be a centimeter squared, a square centimeter. Huh. So there's 6 square. It would be centimeters, but we write it more sophisticated. In 6th grade, we go 6 centimeters squared. See how that's easier? So, all right, next. You can just count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. But you know what some people do? They go like this. They go, wait a minute, Mr. Hoffman. Watch this. 1, 2, 3, by 1, 2, 3. You counted this one twice, though. It's weird, but that's how it works. 3 by 3. So that would be just 3 times 3. And you get 9 either way. 9 what? 9, we'll say units squared. Okay, there's 9 squares. We'll say 9 units squared. How about this one over here? You can go 1, 2, 3, 4. Some people see, oh, there's 5 right away, and there's 2. So it's a 5 by 2, that's 10. Or some people go, count them all. I'd like to count them all. 1, 2. Don't put Dracula in charge of the blood bank. That's not a good idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the point I'm trying to make here? Well, we'll show you because I'm like a circle. I don't have a point. Wait, I do have a point. It's right in the middle, kind of. It's a center, maybe? Anyway, let's see. 10 units squared. Let's go to the next slide and then maybe it'll start to make more sense. Again, you can count, right? 1, 2, 3, 4, but in this case, I probably wouldn't count all of them. I would just count the 4 here and then I'd go across the top, 1, 2, 3, 4, 5, and just go 20. 20 units squared. Same thing here. Who's going to count all this? Well, the count might from Sesame Street, but not us, not me anyway. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, the count of this one twice, but that's just how it goes. 8 by 9 is 72. The year I was born, it's a wonderful year. I was born in 1972. But 72 what? Units squared. 70. If they were acres, we could say if each one of these represented an acre, we would have 72 square acres. Pretty cool, huh? Okay, next. So we usually do length times width. That's the formula. Take whatever the length is. Usually we say this. Say the length of this is 3 and the width is 2. We just do 3 times 2. A 3 and a 2 equals 6. So we didn't put the squares in, but if you did, it would look kind of like this. 1, 2, 3, 4, 5, 6. Well, units squared. 6 squares. 6 square units. So yeah, okay, so this is like old school kind of like sort of. Okay, but we're going to change it. Instead of saying length times width, I want you to use the vocabulary base. Let's make base blue. Base is better blue. Make it a blue base. Blue. Base. It's a light blue, but still, it's a base. Times the height. Height, like height. When they say in Japanese, height. I think that means hello or something like that. That means height. I know, I see it in all the like Bruce Lee movies I watch. So that's the height. Instead of saying length and width, trust me on this one, you want to go with base and height because then you can adapt it to all kinds of situations. You'll be adaptable, improvise and adapt. So I think I learned that first from a Clint Eastwood movie, but anyhow. So base and height, so gone with the width and the length, we're going up a whole nother level, or we're going to go up, level up to base and height. If you're a Japanese person, height. Although they're not very tall typically compared to, well, anyway, let's not go there. That's stay away from that. That's not politically correct. Next, stereotyping. Don't do it. Next. Okay. They kick my butt too. They know that karate and I'm dead in the water or wherever I am, land or the air. No matter where I am, don't do it. Okay, next. Base. Base times the height. 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 Sensei. Sensei. I think they say sensei, like master. I think that means they're master because they teach them how to be like a really good, karate person, kung fu, whatever it is they do. Okay, but that's stereotyping too, because not every person does that. Japanese, Chinese, they don't all know karate, do they? Maybe they do. I wouldn't err on the side of caution and just not mess with them, just in case. All right, 2 times 5 is 10. 60. So this is 60. We would have like to draw like a whole bunch of little squares in here. 1, 2, 3, 4. It'd end up being like 60 squares. So 60 inches squared. Base times height. Where's the base, Mr. Hoffman? There is no base here. Oh, it's the same as this. See, that's 60. So if that's 60, of course, this is 60 millimeters. That's tiny. You know how tiny a millimeter is? It's like the paper clip, the end of a paper clip. Tiny, tiny, tiny. Okay. I'm not going to do this, work this out. You would just do 60 times 11. All right. All right. However, I do love the disappear zero trick. 60 times 11. And because some people don't know this, and it's so awesome, you just disappear the zero for a moment and just pretend like it's not there. Abracadabra. And now what do we got? All we have now is 6 times height. We'll use, I kind of reversed my colors here, didn't I? Oh, does it really matter, Mr. Hoffman? Let's just go with green for the moment. 11, which is 66, right? Now, oh, abracadabra, reappear that zero, that one that we disappeared here. There it is, 660 millimeters, 660 millimeters, what? Squared. That's a bunch of tiny little squares in there. There it is, 660 millimeters squared. Okay, we're gonna skip this one. It should be 15 by 20, 15 by 20, 15 by 20 feet. Now we're getting, see the base. Height. I love this one. Okay, so we got 6 inches by 8 inches. Now, if we put a little square inch in there, hold on, I'll show you what I mean. Okay, I think I got this figured out. So here, we've got some straws. I made this with pipe cleaner and straws. And so you could, you could turn this, it's a parallelogram, but you could slant it. So it's still a parallelogram, but not a rectangle, because right now it's a rectangle, not a square, because a square has to have equal sides. Okay, 5 inches, 6 inches. It's not complete 100% to scale, but I think this will make sense in a moment. So if I were to take this square inch here, boom, 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 and I can duplicate it, right? That's how many can I fit in there? How many square inches will I fit inside of here? Basically, how many inches squared is this particular object? I could copy it, I could paste it, I could just put another one in there. I should be able to fit 5, right? Let's see if I can fit 5. 1, 2, 3. And I probably didn't do this 100% scale. I didn't exactly. But watch what oh, that's pretty close. Let me show you what I mean by that. Because if I go here we go. See, 1 square inch. It's because the line's a little bit thicker. Anyway, so we got 1, 2, 3, 4, 5. 5 by 1, 2, 3, 4, 5, 6. So how many total is that? 30. 30. 5 times 6 is 30 square inches. 30 inches squared. So, but what about this? What if I take that same dimensions, 5 by 6, base times height or length times width? Well, if you do length times width, and we kind of slant it like this, so it's still 6 by 5, but it's no longer a rectangle. It is still a parallelogram though. And what happens? Was that the same area? Is it still going to be 30 square inches? Can I fit 30 of these in here? I wonder if, we'd have to cut a piece here, add it over here, cut it here, add it over here, whatever the case may be. Let's see what happens. Let's try this. If I take this can I fit that in there? Maybe. I don't know. Like if we were to cut it somehow, like cut, let's see, if we were to like cut where that line is here, can we cut these off and fit them in here? I'm not sure. Maybe. All right, let's keep going and see what happens. What if we slanted even more, like this much? Still 6 by 5. Oh, I think it's becoming a little bit more clear that let's see, bring this to the front. Bring it to the front. That it's not going to fit in there. I don't think we're going to I don't think we're going to fit all these in there. Let's go to the next level. What if we slant it this much? Yeah, I think it's becoming more apparent. Oops. Sorry, I didn't mean to bring your parents into the whole situation. Unless you like them, and that's pretty cool. But if you don't like them, sorry. If you just had a fight with them, I apologize. but you'll make up and things will work out. No, I don't think so. Let's just get really extreme. Take to the extreme level. Yeah, there's no way this is going to fit in there. Not going to happen unless you're like a magician somehow. Bring to the front. So, but yeah, so instead of length times width, that's why base times the height will work. Because now you take the base, which is still going to be 6, right? We're still going to use this 6 here, but we are not going to use the 5. Instead, we're going to use whatever this is. Whatever this dimension here is, that's the height. What is that? And they'll give that to us. For example, here, if you have 8 as the base, and say this is, I don't know, 5, we're not using that. No, we're going to use whatever this thing is. This is the height. This is the length or width, whatever. We're not using that. We're going to use this and say this is like, I don't know, 3. We do 8 times 3. 8 times 3. That's what it would be. 8 times 3. 8, 8, 6, 8, 16, 8. You put your 8, 16, and your 24. I think which song to use. Or I can use my 3 song. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So it's 24, and they're using centimeters. Centimeters squared. This would have to be centimeters here, though. There we go. So base times height. That's the trick. Base times the height. Height's on site. How would you find the height of the parallelogram like this one? I don't know. See, where's the height? I guess you could just draw a line straight up like this. Uh-oh, how far do you go? I think you would stop, what, here? That would work, but that's not how they're going to give it to you probably in a test. They're going to give it to you like this. And you're like, what kind of shape is that? Mr. Hoffman didn't teach us that one. I think it would actually be a, just in case you're wondering, just for fun. Oh, time for my meeting. I might have to leave and come back, but let me just at least finish this slide. What kind of shape would this be? Oh, I recognize this. This is so close to this shape right here, which is a trapezoid. However, it's this, if you could draw a line like this, if you were to cut this piece of the trapezoid off, and this is not really part of the lesson. We're finding area of parallelograms, not trapezoids right now. That's another lesson. But so yeah, keep that in mind. So we're looking for the blue one. Everything inside, let's make it green so we can everything. Well, let's make it red. Oh, no, it's already red, Mr. Hoffman. Make it a fat green. Here we go. Thick, wide green. There we go. Everything inside the green. That's what we're looking for. You already know that. All right, so let's move on. We're finding the height. So the height is going to be whatever this line is right there. Oh, by the way, this is a right trapezoid. This is called a right trapezoid. It's still a trapezoid, but it's called a right trapezoid. Why? Because it's correct. It's not wrong. No, it's not left. No, it's, well, it's a right angle. That's why. Okay. And so we'll come back in a moment. See you there. Gotta go to my meeting. Bye. All right, here comes one of the coolest things ever in math. Check out this parallelogram down here. Watch this. Are you ready for this? Come on now. Here we go. There's the height. Here's the base. Ooh, guess what I'm going to do with this little triangle we just made over here? Can you guess? How about now? Any ideas? Now? What do you think? Oh, you're getting some ideas. I hear. I'm being blinded by the lights. The bright lights. The lights are turning on everywhere, all over the world. OM goodness. Watch this. Just like a spaceship landing there. That's it. So really, if you take height times base here, a rectangle, you get the same amount of area, right? As if it were separated like this. Yeah. Amazing. Let me try this one. What is the area of this particular parallelogram down yonder here? This is what you got to be watching out for. Base times height. Base, 9. Height, 3. No, it's not. You know better than that. Don't use that 3. Use that 2. 9 times 3, 18 inches squared. We get like 18. Actually, it'd be a little bit bigger than that, I guess. 18 squares in there. Okay, inch by inch. Okay, which one are we going to use here? Height, base times height. We'll go blue. Height, purple. And you are just a distractor. Don't bother me. How dare you? How dare you? Okay, we're going to use the 6 and the 4. 6 times 4 is 24 centimeters squared. If this were a centimeter squared, we get 24 of those. 1 centimeter by 1 centimeter. This is where it gets interesting. What's the base? What's the height? So I'm going to shade in what we're really looking for. And so I'll pick yellow, I suppose. Oh, it's not yellow. We'll go with green then. Oh, well. We're looking for the area of the parallelogram. Some of you are looking and say, well, what are we finding? The area of the triangle? The area of everything that's left of the triangle? Right of the triangle? No, we're finding everything here. So how do you find that? We just go like this. We'll go blue for base. The 3 and, well, it's not, see, this is 3. The only thing that's 3 is this, right? What about all of this here? What's that? Oh, look up here, people. See this? This is 9. So this is also 9. We don't even need the 3. We just need the base, which is 9. That's like extraneous information. They're trying to trick you. Don't fall for it. And then we need the 8, the height. 9 times 8, the year I was born, 1972. So the answer is just 72, not 1972. So we're going to put 72 what? Feet. And of course we need to put a little square up there. Squared. Better go over this. 72 feet squared. Okay, ooh, more fun. See if you know what you're looking for. You're looking for everything in the blue. Oh, let's go green again. Let's stay consistent. How much little squares can we fit in the green area? Okay. So here's the base. Go blue. 5 and 3. So the base total is 8. So from here to here is 8 centimeters. And then so what's the height? Oh, would you know it right here, 9 centimeters. 8 times 9! My favorite factors put together, 8 and 9, because it equals 72. The year I was born, 1972. So you guys got this now? Try it out and see what you get. Come back, pause the video. Pause it. Have you paused yet? Why haven't you paused yet? You know, life moves pretty fast. You don't slow down sometimes, you just might miss it. That's from a Ferris Bueller movie. Don't know why that came to me just now. All right, so we're looking for the base, which is the 4 and the 8. This line. 4 and 8 is 8, 9, 12 meters. And then the height is here, which is 7 meters. So yeah, you're just doing 12 times 7. 12 times 7, 14, 84? 84 what? Meters squared. Yeah, that's it. This is another lesson. Glad you made it. Have a wonderful day. Panthers, pride, passion, purpose. Peace out.